In this video, we're looking at filtration, crystallization, and other separation techniques. The main learning outcomes is to see how filtration, crystallization, chromatography, and distillation work. This is GCSE Topic 2 for EdXL specification. Key learning questions to do with filtration and crystallization. How filtration is used, how crystallization is used, any hazards and risks associated with filtration and crystallization. Okay, so let's look at some key definitions first. A solution is a mixture of solutes. A solute is a substance that dissolves in a solvent, and solvent is a liquid, and a solution therefore is solute plus solvent. Again, I'm going to use my highlighter pen to highlight some key things as we go along. Crystallization is the technique used to separate a solute like salt from a solution. In other words, to take out a solid that's dissolved in a solution. Crystallization involves evaporation, and it also involves filtration. Okay, so let's look at how crystallization is carried out. Again, this is something we would do in the lab. The main thing in terms of crystallization is we warm the solution with the mixture. We allow the solvent to evaporate, i.e. just evaporate the top layer of the solvent until you have a saturated solution, and then just leave it to cool. Leave it on the windowsill to cool. And that's how you would have your crystals. If you evaporate to dryness, then you will get the salt rather than the crystals. And a solid that does not dissolve in the solution or in the liquid can then be separated by filtration. Filtration does depend on size of crystals. So the smaller the size of crystal, it will go through the filter paper. Now, the size of crystals depends on the rate of cooling. Fast cooling will result in large number of small crystals, and slow cooling will result in smaller number of larger crystals. There's the apparatus for filtration. That dotted line there, that's your filter paper. That's the filter funnel. There's a conical flask, and that's the filtrate here. So filtration is used to separate a solid from a liquid, and we place a filter paper inside the glass and then pour the solution in, and the solid should remain back here in the filter paper. The residue and the solution that goes through is called the filtrate. Summary of crystallization. Here's a nice diagram for you. Dissolve a solid in a solution, filter, evaporate, leave to cool. Those are the easy stages. Filter, so add the solvent, filter, warm the solution, and evaporate a small layer, top layer of the solvent, leave to cool. And that's it. That's crystallization. Risk assessment. Well, crystallization uses steam to heat the evaporating basin. So here's one risk: don't touch the evaporating basin. Other risks could be things like if you heat for longer, the solid could spit out, so you must wear goggles. Remove the Bunsen, and this is a better way to form crystals by heating the water rather than heating the solution directly. Okay, now let's move on to paper chromatography. Chromatography is a method for separating dissolved substances from one another. It's more commonly used for colored substances, so to separate a mixture of colored substances. It works basically depending on how well the substances in the mixture dissolve in the solvent. The more soluble the substance is in the solvent, the further up it travels. Now, this is the key bit of science for chromatography, and we do cover this topic at A level also. In chromatography, substances are separated as they travel. You have two phases: mobile phase, which in your case is the solvent; stationary phase, which strictly speaking isn't the paper, but for GCSE purposes we will say the stationary phase is the paper. Different substances will travel at different speeds, so some move further than the others. The more insoluble the substance, the less it will move up the paper. Okay, now let's look at the chromatogram. The mixture is placed on a filter paper, which is placed in the solvent. Notice, the solvent, this here, I'm going to draw this, is a pencil line, where the spots of the mixture are placed. It's a pencil line because pencil is insoluble in the solvent. The pencil line is above the solvent, there. Okay, as the solvent rises up the filter paper, the individual components start to separate. So we can see here, this substance here is a mixture of two inks, and this one is also a mixture of two inks. So none of these two solvents and none of these two components are pure. The solvent travels furthest up, so there's my solvent line, and these are basically the distance moved by my spots. Okay. The main thing about chromatography is you work out what is RF, or the RF value. RF basically means retention factor. It basically measures how well the solvent interacts with the stationary phase. You just need to know how to calculate it. So RF is the distance traveled up the paper by a component divided by the distance traveled by the solvent. Here's an example. It's basically RF is A, this distance here, that's the distance traveled by the component, divided by B, which is the distance traveled by the solvent. So let's give you a worked example. Here's your worked example. If a component traveled 4 centimeters and the solvent traveled 10, RF is 4 over 10. Please note, no units. Okay. Uses of paper chromatography. Distinguishes between pure and impure substances. Identifies substances by comparing their patterns, and identifies the substances by calculating the RF values. The topic is distillation, and we will look at differences between fractional distillation and simple distillation. Okay, so we're looking at distillation now, and here we will look at fractional and simple distillation. Distillation is a process of separating a mixture of liquids with different boiling points. We have simple distillation, which we can use to separate a solvent from a solution, like water from salt solution. And it works because the dissolved solute has a different boiling point to than the solvent. And the way it works is the solution is heated, the solvent vapor evaporates, and then it's cooled and condensed. We'll have a look at it next. So here's the apparatus for distillation. You do need to know this apparatus. Please note this is a condenser. It's a condenser because as the mixture is heated, it evaporates, forms a gas, goes up, comes out of this side arm, comes into the condenser, which has water going around it, and then it's collected as a liquid. So these are the two stages. The solution is heated. You can pause the video here just to have a read of this. So heating, boils, vaporizes, and then in stage 2 it condenses and it's collected as a liquid. It's simple. Next one is simple distillation, which can be set up like this in the lab. Basically, you got a conical flask with a delivery tube, salt solution, heat, and you just collect the water at 100 degrees. Let's look at fractional distillation. The only difference between simple distillation and fractional distillation is you've got a fractional column, which is cooler at the top, hotter at the bottom. The rest of the process is exactly like the simple distillation. The mixture heated, and there are several liquids here now which boil at different boiling points. The lower boiling point liquid will evaporate first. Out of the side arm, it's condensed and collected as a liquid. You can read the rest of this yourselves. Please pause the video and just read this information for yourselves. Okay. Fractional distillation can be used to separate ethanol from water. Okay, last one then, drinking water. Just look at how we purify drinking water. The first process you need to know is desalination. So there are many countries in the world which use seawater, which get drinking water from seawater. Desalination simply is a process that removes minerals from seawater by using simple distillation method. So you can just see you've got a pan with water. This is like a glass tubing, and the water boils at 100 degrees. The steam hits the glass tubing where it cools, and then it's collected as droplets of water, and that's how water is made. Very expensive process because it needs a lot of energy. Last slide then, purifying water for drinking. This is a really important diagram. Basically, in the UK, water comes from many sources, from wells, from pools of water, from sewage and things like that. Water we've already used from washings and all of these things, like bath water, like water used for washing dishes, etc. So the water is filtered first, then it is chlorinated. So these are the processes that's happening here. The water filtration removes solids in the water such as leaves and soil. There is a sedimentation tank. There is a filtration tower where sand and gravel stick to the bottom, and then the water is drained and goes into a tank where chlorine is added, and chlorine kills bacteria, and then pure water or drinking water for homes is ready for us. So different sides, and then you can read the rest of the points yourselves. And that's the end of my video.